All right, if you're watching this, that means you were absent today, and I made this video to help you catch up. All right, so we're going to be on page 23 of the Unit 5 packet, and today we're talking about algebra properties. And a property, it's not like a property like a house or anything. A property in algebra is like a characteristic. Okay? A property is kind of it's like a thing about algebra that's true. It's a characteristic. Whoops, missed a couple letters there. All right, so there's three different properties that I'm going to show you today, and that we're going to work with. There's one more property that we're going to work with next time that's going to be really important as well, but we'll just focus on these three today. The first one, I know the letter's missing, but it's called commutative. I'm going to write it here. Commutative. Now, it says the order in which two numbers are added or multiplied does not change their sum or product. So this one, I'm going to use a highlighter. You know what? I'm not just going to underline it in pencil. I'm going to use a highlighter. So the order in which two numbers are added or multiplied does not matter. It does not change the sum or product. So this is a multiplication and an addition property. It's a characteristic of addition and multiplication. And when you think of this word commutative, there's a word in here like that's called commute. And commute is like if you talk about like your morning commute, it's how you get from home to school or from home to work. So commute means to move around or to move from one place to the other. So it says the order in which you add or multiply does not change the sum or product. So if you move the numbers around in addition or multiplication, it doesn't change the answer. So when you add, if you do 7 plus 9 or 9 plus 7, the sum is still the same. If you use a variable like a plus b, but you do b plus a, again, those are equivalent. They have the same value. Same is true for multiplication. If you do 4 times 6 or 6 times 4, you get the same product. A times b or b times a, you get the same product. So we're going to think about this property, commutative property, that the numbers can move around in addition and multiplication and not change the value. And we're going to see if we can find any equivalent expressions here using that property. So let's look at this. 15 plus 6 and 6 plus 15. Are those equivalent? Yes. Are they equivalent? Yes. Explain why. Yes. The reason why they're equivalent is we could say addition is commutative. Okay? That means that, again, you can move the numbers around and the answer is the same. That's a property of addition. 12 times 4 and 14 times 2. Are those equivalent? No. No, they are not equivalent. Why are they not equivalent? The numbers and products, meaning the answer, are different. So like 12 times 4 is 48. 14 times 2 is 28. So those aren't the same value. If you look at the first one, 15 plus 6 is 21. 6 plus 15 is 21. We just changed the order. All right. 10 times 6 and 6 times 10. Are those equivalent? Yes. All we did was change the order of what we multiplied. We didn't change the value of any of the numbers. We just changed the order. So, yes, they are equivalent. And we'd say, well, multiplication is commutative. We can change the order of the numbers, and the value does not change. All right, let's take a look at this last one here. 12 divided by 3, 3 divided by 12. Are those equivalent? No, they are not. Why? Well, they have the same numbers and the same operation, but division and subtraction, division is not commutative. You cannot just change the order of a subtraction or a division problem and get the same answer. It's not commutative. It only works for addition and multiplication. So that's called the commutative property. All right, the next one is the associative property. I'll write that out because, again, part of the word is gone. Now, it says the way in which three numbers are grouped, that's a key word. The key word up here, by the way, is order. This is the group. The way in which three numbers are grouped when they are added or multiplied. Oh, look at that. Same as the previous one. Does not change their sum or product. So the NBA, the National Basketball Association. Association means like a group. So you can kind of see that word association here. It's not necessarily there 100%. But that word association kind of means group. Like the NBA is a group of basketball teams. An association is a group of people, or in this case, it's a group of numbers. So what associative property is saying is, if we have the same numbers in the same order, 3 plus 9 plus 4, 3 plus 9 plus 4, and we group them differently with parentheses, it's not going to change the sum. So you can see that here with variables as well. If you have the same numbers in the same order, the order does not change. The order stays the same. But if we just group them differently, then it's the same value. Same thing with multiplication. If we multiply 8 times 5 times 7, 8 times 5 times 7, but we group them differently, you still get the same answer. Still get the same answer. Notice, these aren't like mixed together. It's not like multiplication and addition together. No, it's all multiplication or all addition, not mixed together. So the numbers are in the same order, just grouped differently. So let's see if we can find some equivalent expressions. All right, so we have 15 plus 5 plus 8, 15 plus 5 plus 8. They're just grouped differently. They're both using addition. Numbers are in the same order. Yes, these are equivalent. Why? Addition is associative. We can group the numbers differently. Same order, just grouped differently. All right, let's check these out. 20 minus 12 minus 3, 20 minus 12 minus 3. Same orders, grouped differently, but it's subtraction. So let's just check this one real quick, because these should not be equivalent. 20 minus 12 is 8. 8 minus 3 is 5. That one's equal to 5. I'm just going to write that. For this one, we do 12 minus 3 first. 12 minus 3 is 9. 20 minus 9 is 11. So that one's 11. So these are not equivalent. Why? Subtraction is not associative. Subtraction does not have that property. It is not true for subtraction. All right, let's check this one out. We got 5 plus 6 plus 3, times 5 times 6 times 3, 5 times 6 times 3, different groups. Are they equivalent? You bet they are. These are equivalent. Why? Multiplication is associative, meaning we can multiply three numbers together, but group them differently and still get the same answer. That's kind of nice. Let's check this one out. 35 plus 17 plus 43. 35 plus 17 plus 43. You can see the groups are different. Are these equivalent? You bet they are. And why? Well, it's the same reason as the first one. Addition is associative. Oh, I love this last one. It says 15 divided by 3 times 2. 15 divided by 3 times 2. Are those equivalent? Now, some people might say, oh, well, division doesn't have an associative property, so it can't be because I see division there. However, these are equivalent because they're just the same exact thing. They're just the same expression. 15 divided by 3 in parentheses times 2. 15 divided by 3 in parentheses times, it's the same thing. If we group them differently here, then they would not be equivalent. If this was like, if the parentheses were on the 3 times 2, they would not be equivalent, but they're just the same exact expression. So yes, why? They are the exact same thing. The grouping's not different, the order's not different, so they're equivalent. Okay, so that was a bit of a tricky one there, but there it is. Okay, so that's 23. We got one more property to talk about, and that property is called the identity property. It says the sum of an addend and 0 is the addend. That's one of them. That's the one for addition. Let's go right there. This is the addition identity property. Okay. The product of a factor and 1 is the factor. Well, that's the multiplication identity property. Just going to write that here. Multiplication. Just going to fold the page over. All right. So let's take a look at those. The sum of any number and 0 is just that same number. The product of a factor and 1, so the product of any number and 1 is just that number back. And you can see that in addition. 13 plus 0, anything plus 0 is itself. 13 plus 0 is 13. If you have a variable a and you add 0, you just get a back. With multiplication, 7 times 1 is 7. Any number times 1 is that same number. Or if you look at a variable, a times 1 is just a. It's just a. So when I think about identity, I think of almost like looking in the mirror. And when you look in the mirror, you see yourself. It's kind of like if you add 13 or 0 to 13, you just get itself back. So it's identity, I think of it's yourself. Get yourself back. There's only a couple examples here we're going to check out. 34 plus 0 and 34. Are those equivalent? Yes. And they're equivalent based on the identity property of addition. So when you add 0 to anything, you just get the same number back. 9 times 1 and 9, are those equivalent? You bet. Why? Same reason. Similar reason. Identity property of multiplication. Okay. There you go. So you add 0 to anything, you multiply 1 by anything, you just get that same thing back. Just get yourself back. All right, so we're going to look at a couple of different types of problems here using these properties to help us. It says in a recent season, the Kansas Jayhawks, which is a college basketball team, had 15 guards, 4 forwards, and 3 centers on their roster. Write 2 equivalent expressions using the associative property that can be used to find the total number of players on the roster. Now, to find the total number of players, we can add them together. 15 plus 4 plus 3. Now, associative property, I think of groups. And when I think of groups, I think of parentheses. So what we're going to do is group these numbers in a certain way. Let's group together the 15 and the 4. And then it says to write 2 equivalent expressions. Well, there's 1. So we want to write another one that's equivalent to that using the associative property. So I'm going to keep the numbers in the same order because associative property says that if the same numbers, same order, we can just group them differently. So I'm just going to group the 4 and the 3 together. Same answer. They're just grouped differently with different parentheses. 15, 4, 3, 15, 4, 3, just different groups. All right. That's the associative property, grouping. Brandy earned $7 babysitting and $12 cleaning out the garage. Write 2 equivalent expressions using the commutative property which is moving from one place to another, that can be used to find the total amount she earned. Well, how are we going to find the total amount Brandy earned? 12 plus 7. Commutative property means we can move the numbers around but still get the same answer. The other equivalent expression, 7 plus 12. Oh, yeah. Okay, now this last one's a little tricky. Let's see what happens. It says the area of a triangle can be found using the expression 1/2 base times height, where b is the base and h is the height. Find the area of the triangle below. It looks like a water slide of some sort. All right, so I'm going to use this expression. You may have seen something like that before, probably area equals base times height. This is for a triangle. So the base is, looks like the base is 15. This is the base, and the height is 12. So I'm going to put those numbers in for the variable. So 1/2 times the base is 15. I'm going to write it as fractions. 15 over 1 times 12 is 12 over 1. Now, here's the thing. If I were to keep it like this, I would have to just multiply the numerators and then multiply the denominators and then divide by 2 at the end. But I kind of want to simplify that 2 and 12, but they're not next to each other. However, we can use the commutative property to move the numbers around so that the 12 and the 1/2 are next to each other, like so. All I did was move or change the order. We can do that because it's multiplication. Now I can simplify the 12 and the 2 because they're right next to each other. 2 becomes 1, 12 becomes 6. 1 times 6 times 15 would be 90. 1 times 1 times 1 is 1, so the answer would just be 90. These are all equivalent. Again, I just switched the order of the numbers to make simplifying a lot easier to do. All right. Now, these are a little tricky. We're not going to do all of these, but these are kind of tricky. It says use one or more properties to rewrite each expression as an expression that does not use parentheses. So if you look at something like this, well, I can't add together y plus 1. I also, right now, can't add together 1 plus 4 because the 1 is not in the parentheses with the 4. And order of operations says that we have to do parentheses first. But here's the thing. Because this is adding, I can keep the numbers in the same order and just group them differently. 1 plus 4 is just 5. So I changed the parentheses using associative property. Now I can write this expression, y plus 5, without parentheses, because I can add together the 1 and the 4. This one right here is kind of similar, but also a little trickier. I can't do 6 times r. I don't know what r is, but if I can do 6 times 7 if I get them next to each other and in the parentheses. So the first thing I have to do is get them closer to each other. I'm gonna use commutative property to switch the r and the 6. Then I'm going to use the associative property to group them differently so that I can get rid of the parentheses. So r times 42. So notice I had to do 2 steps there. I had to get the r 6 closer to the 7, and then I had to regroup it to make it 42. All right, we'll try one more of those. Let's do this one. So same thing, like I want to get the 3 and the 5 together because I can add them, but I can't add them if the 3 and the z are in parentheses because then I have to do that first. So I'm going to move the 3 closer to the 5, z plus 3 plus 5, using commutative property. I just switched the order of the numbers. And then I'm going to group them differently using associative property. I'm going to group the 3 and the 5 together. Well, what's 3 plus 5? It's 8. It's 8. You know what? Let's just do this one for good measure. So I want to get the 8 and the 4 together, but I don't know how. But I do. I want to get the 8 and the 4 together using 2 properties. First, we're going to have to use commutative property to move the 8 closer to the 4. And then we'll use the associative property to group them differently so that we can multiply 4 times 8. Well, what's 4 times 8? It's 32 times f. Ta-da! All right, last group of problems here, and we'll be all set for today. It says, find the value of x that makes the statement true. Well, if you look at this, 24 plus what is 24? Well, that's identity property, because if x was 0, 24 plus 0 is just 24. That's identity. 17 plus something equals 3 plus 17. Well, if that x was 3, that would be the commutative property. You just switch the order of the numbers, but you still get the same answer. This looks like associative property to me. We got the numbers in the same order, kind of. We're just missing one. 14, 3, 4, something, 3, 4. Just group them differently. For those to be true, that x would have to be 14. And then last but not least, what would you have to multiply by 18 to get 18? Well, the only number I can think of is 1. 18 times 1 is 18, and that is the identity property of multiplication. All right, so those are 3 properties that we're going to be using, and they're going to be helpful to us this year and beyond. I hope you have a good day, and let me know if you have any questions, and I'll see you soon. Bye-bye.